Before we dive into the next item on our list of computational fundamentals, the array, I want to shift the paradigm of the program I'm writing for a moment towards the creation of a simple interactive game. Apple Basic does actually have a graphics mode where you can draw shapes and animate them, but an even simpler way to start is just set the position of a particular character on screen. The display space on this old Apple II Plus is a grid with 40 columns across and 24 rows up and down. I like to think of them as pixels on a very low resolution display. If I want to place a character at a particular location, I can use the commands H-tab for the horizontal column and V-tab for the vertical row. So first, I'm going to start with line 10, and I'm going to set two variables. One for the horizontal position, I'll call that X, and one for the vertical position, I'll call that Y. Then, once I have those two variables, let me clear the screen by saying home on line 20. And then I will set the H-tab and V-tab to set the position. H-tab is set to X, V-tab is set to Y. And notice, by the way, I'm pairing groups of code together. Like when I want to declare two variables, I might as well put them on the same line with a colon, H-tab and V-tab on the same line with a colon. Just makes things nice and neat and tidy, which is something I really do enjoy. Then, once the position is set, all I need to do is print whatever I want to print. In this case, I'm going to use a star or asterisk, and then I can just run this program. There we go. Look, it cleared the screen, and the star appeared 5 columns over and on that first row. Now, let's think about it. What if what I want to do is animate the star coming down? So I can add a line of code to increment the value of y. Y equals y plus 1. Then using goto, I can go back and print it again. Increment, print, increment, print. Now where, though, should I go back to? I definitely at least need to say go to 30, because I've got to set the new horizontal and vertical location, but I think I'd like to go back to line 20, because I want to clear the screen each time, so it looks as if that star is moving downwards. So line 60, go to 20, and let's give it a try. Oh. So, of course, I should have thought of this in advance. I'm going to get an illegal quantity error in line 30, because on line 30, I'm saying V-tab Y, and at some point, Y is going to become 25, which is a row that doesn't exist on the screen. So this is the perfect time for, maybe you're thinking what I'm thinking, a conditional statement, right? I've got to sandwich it here in between lines 50 and 60. So line 55, if y is greater than 24, right, that's an invalid row, what should I do? Well, I could end the program. There's any number of things I could do, but what I'm going to choose to do is set y back to 1. So now it's back to 1. If I run this program, there it is. Star is infinitely moving down, cycling back to the top. It's moving really fast. So let's add one of those for loop pauses in just to slow down the animation a bit. Let me see, where would I add that? So I'm running out of space here, but I think it makes sense to add it right after that if statement and right before the goto. So I'm going to add line 57 for pause equal 1 to, and let's just say 200, and then next pause. Okay, let's run this. There we go. Look at that nice star. All right, so why am I even doing this in the first place? It took a while to get here, but the whole point is I want to ask the question, what if I want a second star, or maybe a third, or a fourth? Maybe I want 10 of them. I want 1,000 of them on the screen. All of this is possible. How would I do it? So an array is going to be the answer, but let's get ourselves there a bit more slowly. So your first instinct might be, let's do something like, oh, I could print a second one in between lines 40 and 50. So on line 45, I could print a second one 5 spots over at the same y, and then I'll just even add print here on this same line. And I could run this. Look, I've got 2 stars, but this isn't really getting me anywhere because they can't move independently from each other. They always have to be relatively positioned to each other. So perhaps a better solution might be to have a second set of x and y variables, right? One x and y for one star, another x and y for a second star. Let's try that. So if I go to line 15, I'm going to add a second x. Let's make it at 10. And let's have the second y be a little further down at 4. Then after I print the first star on line 45, I can H-tab for, what was it, x2, and V-tab for y2, and then print that star. And oh, now I have to increment the second y. Oh, and look, I made a mistake there. So let me retype line 15 because that needs to be a y2. The one downside of putting multiple things on one line, I've got to type it all again. Okay, that's fixed. So now I need to also increment the second value of y. I'm really running out of space here. So I'll put that on line 52, y2 equals y2 plus 1. Then I have to do the if statement for the second y, 56. If y2 is greater than 24, then y2 also equals 1. Whew, a lot of typing. Let's take a look at this. 2 x's and y's, clear the screen, draw the first star, set the location for the second one, draw it, increment them both, if statement them both, pause, repeat. Let's give this a try. And there we go, 2 stars moving independently. To really show you that they're moving independently, let's add something a little bit fun here. Whoops, which is, let's have the first star move faster. So if I say on line 50, y equals y plus 2, and I run it, look at that. That first star is catching up to it and passing it. It's moving faster than the second one. So this is great and a nice demonstration of how variables and conditionals work and goto and the flow of how you might create an animation. But I'm really missing something here. Now if I want to add a third star, I mean, come on. Let's look at this code. I'm gonna need another line of code for an x3, y3, then I need another line of code to increment y and another if statement. This is not sustainable. You know, maybe I could manage 3, but once I get to 5, once I get to 10, the code is going to balloon out of control. And this is exactly where an array comes in. An array is essentially a variable that allows me to store a list of numbers. So I can have in one variable a list of all the x's and another variable a list of all the y's. And this is going to make things much easier. The key word to use in BASIC for creating an array is dim, which refers to the dimensionality of an array. In truth, you can think of an array of numbers as a table, a spreadsheet of any dimension, if you will. But to keep things simple, I'm just going to concern myself with one-dimensional arrays right now, a linear list of numbers. So moving back over here, I'm going to type new to clear what was there before. Then I'm going to type dim x. I want to have an array of horizontal values, parentheses 4. Now, what does that parentheses 4 mean? It's talking about the dimensionality of the array, 4. Does that mean there are 4 things in the array? Actually not. So this is a weird thing in programming. Programmers often count from 0, and this really makes a lot of sense for various things you need to do with software. So if I start counting from 0, 0, 1, 2, 3, 4, that is actually 5 values. So the length of this array is 5, but when I'm creating the array, I need to specify the maximum index. So this term index is really key. Let me show you what I mean by that. I can set the 0 value of the array equal to 100. Then I can do index 1, negative 3. Index 2, index 3, index 4. There, I have now declared an array with 5 spots and set the value of every single one, index 0, 1, 2, 3, 4. Now if I want to individually address one of those elements, I just need to refer back to that index. So I could say print x2, and I print out the value 6. So it would be very normal for you to be thinking right now, how is this any better? I mean, you were saying before, like, I don't want to have separate x variables and separate y variables, but don't I have that here? x0, x1, x2, x3? Well, the fact that we have this index value that is counting up from 0 to 4, anything that we've done before maybe remind you of that? 4, an index that goes from 0 to 4, right? A loop. So what I can actually do with an array, and let's start over and put this into a program, dim x4 as the first line. Then what if I were to say for I for index, equals 0 to 4, and then on line 30, I were to say x index I, right? I is 0, then it's 1, then it's 2, then it's 3, then it's 4. So I'm going to individually address every element of the array with the variable I. And let's just set it equal to itself right now. We'll set it to I. So I'm actually putting the index into the array. And then on line 40, I would say, oh, let's print it out. Print x index I. On line 40 and then line 50, I will say next I. What's going to happen when I run this code? 0, 1, 2, 3, 4. Now, this is what's kind of exciting. What if I wanted those stars that I'm about to place to be spaced out by 5 columns each one? So now we just got to use a little basic arithmetic here. So what if I want element 0 to be at column 5 and element 1 to be at column 10? Let's think about how I can do this. I only need to edit line 30. X index I equals, well, the index 0 should be at 5 plus, and then every subsequent one should be 5 more over, I times 5. Do that math in your head a little bit. When I is 0, I get 5. When I is 1, I get 10. When I is 2, I get 15, and so on and so forth. Now, if I run this, 5, 10, 15, 20, 25. Amazing. Now, let me show you something really crazy. I can now change line 10 to dim x, and let's say 99, because I want to have an array of 100 numbers. Then on line 20, I can say for I equals 0 to 99, and I'm going to run this code, and look at that. I am now printing 100 values that are all stored in an array, and look at this. I only have 5 lines of code. This is fantastic. We're ready. We can take this concept of an array now and put it into our stars program to have multiple stars all falling from top to bottom without making a mess of our code. I've loaded the falling star program back into the computer. Let's take a look at it. One thing you'll notice that I did is I've reorganized it a bit, and I've had the line numbers go up by 100 now, because I know that when putting in the array, I'm going to need to add a whole bunch of things in between different lines of code, and this will give me more space to work with. So what's the first step? First thing I need to do is replace the single variables x and y with an array. So on line 100, let's declare 2 arrays, dimensions x with 4, that's 5 spots, remember, y also with 4. Okay, now I need to initialize those arrays using that same for loop I just did. So I've got to retype that same code for I equals 0 to 4, x index I equals 5 plus 5 times I, y index I equals 1, 140, next I. So let's just pause for a second and take a look at the code. This looks right. So instead of declaring just those first 2 x and y variables, I'm filling up 2 arrays. What's next? Now, when I'm setting the horizontal x and y location and incrementing the value of y and having this if statement, all of that needs to be inside of a loop so that x and y are always referring to the spots in the array. So another loop should go in between line 200 and 300. So let's put it at 250 for I equals 0 to 4. And then where does the loop end? Right before line 800. So let's add that in at 750. Next I. And then anywhere there's an x or a y, I just need to replace that with the array. 300 h tab x index I. V tab y index I. Okay, what else? Line 500 y index I equals y index I plus 1. All right, am I missing anything? The pause is fine, doesn't use a y. Line 700. If y index I is greater than 24, then y index I equals 1. All right, let's look at all this code together. It's possible I've made a mistake. We're going to run it to find out. But you can see this looks very similar to what we had before. The only thing different is anytime I was referring to x and y, I am now referring to x with an index, y with an index. And the for loops are controlling what those indexed values are. All right, quickly scanning this. I don't see any obvious mistakes. Let's try running it. Oh, look at that, was weird. Oh, the pause. This is a really interesting bug that just happened accidentally here. I kind of love it though. It's drawing all the stars one at a time. Let's look at why that is. It's because the pause is inside of the for loop. So as I'm going through each star, I'm pausing before I get to the next one. I really don't want that. So what I'm going to do is I'm going to clear line 600 by typing 600, and then I'll put the pause after next I, after the loop finishes. So we'll put that at 760 for pause equals 1 to 200, next pause. All right, ready? I think this is going to be what I meant for it to be. There we go. Look, there's all 5 stars falling down. I'm thrilled this is working. I love seeing all these stars, but it isn't that interesting. After all, they're all just on the same row, and I would much rather see them spread out at all different locations on the screen. So guess what? Almost all programming environments come with something called a pseudo-random number generator. It's pseudo-random because it's not true randomness. There are patterns that you could detect in there, but it's plenty good for our purposes. In BASIC, the command for random numbers is rnd. rnd parentheses 1 will give you a random floating point or decimal value between 0 and 1, like 0.335789. I can take that value and multiply it by the number of rows on the screen, right? If I have a number between 0 and 1, multiply it by 24, I now get a number between 0 and 24. All right, let's give that a try. I'm going to control reset here. Let's take a look at the program. And I can't believe this, but I think I only need to edit one line of code, just line 130. Instead of initializing the array to one single value like 1, I can say rnd 1, multiply it by 24, just like I said. I can run the program, and there we go. I have all 5 stars, all at different rows, all falling down. This is actually very similar to something called a particle system, which is a very common computer graphics application that people program today. And wow, look at that. Arrays and loops together at last. Now you might be asking an important question. Aren't the values for the y positions numbers like 9.84323? Can you have a v-tab, a row, at a decimal number? No, you can't. But BASIC here is choosing to accept a decimal value and most likely just removing it in order to set the vertical position to just 9. Some programming environments might round the number, rounding it up to 10, but here it's just removing it. In modern programming languages, this is called a floor operation. All right, this is pretty great. Did you think that in just a few lessons, we'd have a whole simulating snow program? It's basically a particle system, but on a 40-year-old computer. I've got one more fundamental concept for you to just unlock the rest of what we need to finish off this class. It's called functions.